Hey guys, here's a video just explaining a little bit of the why it works. In the first video, we had an inscribed angle, and I basically showed you, on Geometer Sketchpad that it was always half based on what we saw. But of course, that doesn't always have to be the case. And I want you to really see the why. So if you clicked on this video, you're really interested in how come this works. Okay, so here's your inscribed angle. Let's call it ABC. Here is your intercepted arc, right here, arc AC. And again, you already know what the pattern is. You know that, if this was 100 degrees, this is 50. This was 15 degrees, this would be 30, etc., etc. How come that works? So here's how you do it, or here's how you would explain it. If you have the center of the circle here, you can actually draw in the radii that connect to your vertices here, your A and your C, your arc. So if you've got this here, you could also draw in this piece. Okay, that didn't come out so good. Let's just thicken that up a little bit. Okay, so you got lots of little pieces here, but check this out. This is a radius of the circle. This is a radius of the circle. This is a radius of the circle. Even this is the radius of the circle. So all those are the same. Try focusing your eyes in on this bottom part here. This triangle. Let's call that point O. Triangle OBC. In triangle OBC, you have two sides that are the same. That's an isosceles triangle. That means that these two angles have to be the same. Okay? So let's call that little a and little a. They have to be the same. How about over here? You have another isosceles triangle, triangle AOB. Let's call that little b and little b. Okay? So right now I've got two isosceles triangles. These angles don't have to be the same. Obviously A and B don't have to be the same here, but whatever this angle is would have to be the same as this angle. All right, and here's where the shenanigans kind of comes in. You have to really look closely. Try to focus your eyes in on triangle ABO. Can you guys see how there's this piece here on the outside? If this is B and this is B, we actually know what this is, because we learned a theorem a long time ago that looked like this. Remember, it was like 1, 2, 3, 4, depending on how your teacher showed it to you. But we learned a theorem a long time ago where you have an exterior angle, and that's equal to the sum of the two angles on the inside of the triangle that the exterior angle is not next to. They call it the non-adjacent interior angles. Okay? Or remote interior was another way they put it. So this angle equaled these two angles together. That means this angle equals those two angles together for the same reason. So this is 2b. Draw your eyes, focus your eyes in on the triangle down here. Triangle BCO. Same thing happens. I have the two angles here, but I also have an exterior angle here, which is equal to those two together. So this is 2a. Well, we learned in the beginning of this chapter that when you have a central angle, that's equal to the arc. So if this is 2b degrees, then this arc that it hits is also 2b degrees. That would be from here to here. I know I didn't give that a letter, but that's where it would go.
Anyone from the musical?
If I'm looking here at this central angle, 2a, well then this arc has to be 2a degrees from here to here. So the grand total from A all the way to C would be 2b and 2a together, plus 2a. Now go all the way back to the beginning of this problem. Do you remember the first thing I did? I drew in an inscribed angle at B. Okay? I drew in the... Oh, actually, no, I'm sorry. I'm so sorry. I did draw it at B, but I just darkened the wrong part. A, B, C was the original. This was the original right here. All the way from here to here. If you rewind the video, you'll be able to see it. The first thing I did was I drew A, B, C. Okay? That's this entire thing. This entire thing is made up of B and A. So this is B plus A. Well, look at that. This is B plus A. This is 2B plus 2A. Take out a 2 from there, and you're left with 2B plus A. It takes two B plus A's to make this arc. That's because this arc is exactly double the inscribed angle. Okay? So again, if you look at the pieces that made this proof, it comes from things we've already learned. We've learned isosceles triangles. We've learned the radii are congruent. We've learned the exterior angle theorem. And then we've learned the central angle matches with its arc. So you can do this. I mean, you don't need to do this proof. I'm just saying you can follow this proof, at least the logic of it, to understand why, no matter what, if you have a picture that looks like this, and you know this is, say, 37 degrees, why you're allowed to say that, oh, okay, 2 times 37 must be 74. Done. Okay? And there's your explanation of why the inscribed angle is actually half the intercepted arc. If you have any questions on this, please feel free to ask. And don't worry, your warm-up will not have you do this. Okay? It may have you do this, though. Okay? So make sure you can do these kinds of things. But that's the explanation for why it works. Okay? Let me know if you have any questions. I will talk to you guys later. Bye.